Fundamentals of environmental chemistry. Classification of elements. Elements are classified based on their properties into several categories. Metals are good conductors of heat and electricity, malleable, ductile, and have high melting points. For example, iron and copper. Non-metals are poor conductors of heat and electricity, brittle in solid form, and have lower melting points. For instance, carbon and sulfur. Metalloids have properties intermediate between metals and non-metals, for example, silicon and arsenic. Stoichiometry involves the calculation of reactants and products in chemical reactions. It is based on the conservation of mass, where the total mass of reactants equals the total mass of products. Gibbs's free energy determines the spontaneity of a process. The change in Gibbs's energy, or dG, is calculated as the change in enthalpy, dH, minus the product of the temperature in Kelvin and the change in entropy, ds. A negative change in Gibbs's energy indicates a spontaneous process. Chemical potential. Chemical potential is the change in the Gibbs free energy of a system when an additional amount of substance is added. It plays a crucial role in phase equilibrium and reaction dynamics. Chemical kinetics. Chemical kinetics studies the rates of chemical reactions and the factors affecting them. The rate law expresses the reaction rate in terms of the concentration of reactants. The rate is proportional to the product of the concentrations of the reactants, each raised to a power that represents the reaction order. Chemical equilibria. Chemical equilibrium occurs when the forward and reverse reaction rates are equal, leading to constant concentrations of reactants and products. The equilibrium constant, or K, is the ratio of the product of the concentrations of the products, each raised to the power of its coefficient, to the product of the concentrations of the reactants, each raised to the power of its coefficient. The solubility of gases in water is influenced by temperature and pressure, described by Henry's law. The concentration of the gas in water is directly proportional to the partial pressure of the gas above the water. The carbonate system is essential in regulating pH in natural waters and involves equilibria among carbon dioxide, carbonic acid, bicarbonate, and carbonate. Carbon dioxide reacts with water to form carbonic acid, which dissociates into hydrogen ions and bicarbonate ions, and bicarbonate ions can further dissociate into more hydrogen ions and carbonate ions. Unsaturated and saturated hydrocarbons. Saturated hydrocarbons, also known as alkanes, contain only single bonds. For example, methane and ethane are both alkanes. Unsaturated hydrocarbons contain double or triple bonds. Alkenes contain at least one double bond, for example, ethene. Alkynes contain at least one triple bond, for example, ethene. Radioisotopes. Radioisotopes are isotopes of elements that emit radiation as they decay to a stable form. They are used in various applications, including medical imaging, treatment, and environmental tracing. Examples include carbon-14, used in radiocarbon dating, and uranium-238, used in dating geological formations.